Reflection. Reflection is a pretty cool principle, but it's pretty easy. Imagine we have a flat reflecting surface. We're going to have a ray of light come into that flat reflecting surface. We call it the incident ray. That's the incoming light ray. Once it hits the surface and is bounced off, we call it the reflected ray. I don't know if I have to define that for you, but that's the ray that's reflected off. Now, we don't measure this angle. We measure according to the normal. We'll go ahead and define that. The normal, and we're used to seeing the word normal, especially in this context, is a line that is 90 degrees to my surface. So angles are measured with respect to, that's WRT, the normal. So the angle of incidence and the angle of reflection are measured with respect to the normal. This gets important when we talk about curved reflecting surfaces, and I'll show some of those in class, but it's reflection with respect to the normal. And for reflection, we have that the angle of incidence has got to be equal to the angle of reflection. If this thing comes in at 45 degrees, guess what? It has to leave at 45 degrees. That's how all reflection works. That's how all reflection works. So over here we have a simple example of reflection. I'm going to use thinner lines here. So we're going to draw a couple of rays coming off of our object, mostly the top of it. So imagine a ray of light coming off the top of this object hitting the mirror. Well, it's going to be reflected in such a way that this angle and this angle are the same. And if we imagine another one coming in and being reflected out, it's going to work in such a way that those two angles appear to be the same. Now, we're going to talk about why we see a reflection. So you're going to have to deal with it. I'm not great at drawing eyes, but let's pretend this is an eye, with eyelashes and all that stuff. As you see these two bits of light, what you do is trace them back to where they might be coming from. You trace them back to a potential source. And what you see is a place behind the mirror where those rays appear to be coming from. And behind the mirror, this is a terrible illustration by the way, behind the mirror, your eye forms an image. But this is a little bit unique. This is a virtual image. The reason it's virtual is because light rays do not cross to form it. It's virtual because it's your eye tracing these light rays back to where they come from. That's just how your eye sees things. At the same time, looking here, we have two rays coming off of it. When your eye sees it, it only sees these rays and traces it back to the place where the actual object is. That's a real image. It's a real object. But it's a real image because light rays cross. That's how we get real images. Virtual images happen when our eyes trace light back. They trace light back into something. This is a mirror. There's nothing behind it. Our eyes trace the light ray back to it. But that's why we see the exact same image. This law of reflection tells us how the things will be, how they'll look. And that's reflection.